I was just thinking about this brutal high school calculus problem I had. It honestly looked like ancient hieroglyphics. I was totally defeated and just ready to quit.
Oh, I have definitely been there. It is the worst feeling when you just hit a wall.
Right. But then my teacher walked by, tapped my desk, and just said, "I believe in you. Keep going." And,
Yes.
well, you know what? Something actually clicked and I solved it.
That is so crazy how just a tiny bit of encouragement can do that. It like totally shifts your perspective.
Exactly. And it is wild because going through the research you sent over for today's deep dive, I found out that even highly advanced artificial intelligence needs that exact same pep talk sometimes.
Yeah, it is a fascinating story.
We are looking at how an AI named Claude tackled one of the universe's greatest mathematical mysteries today. And speaking of AI making an impact, if you are ever trying to uncover where AI agents could help your business or personal life, you have got to check out embersilk.com.
Oh yeah, they are great for that.
Totally. Whether you need help with AI training or automation or software development, Embersilk is definitely the team to call. But the AI impact we are exploring in your sources today is, it is on a whole different level. We're talking about Claude establishing a massive new mathematical lower bound for the famous Riemann zeta function.
Yeah, and to really grasp what happened here, we sort of have to look at what that function actually does, because for over a century, mathematicians have treated the Riemann zeta function as this ultimate key to understanding prime numbers.
Right. I have heard it called a genetic blueprint before.
Exactly. But honestly, a better way to visualize it based on these notes is like a rhythmic frequency.
Oh, like musical beats.
Yes, exactly like that. The function has these specific zeros, and you can think of those zeros as beats that dictate exactly where prime numbers pop up along the infinite number line.
Okay, so they map out the primes.
Right. And the great mystery here, the 1859 Riemann hypothesis, it basically assumes that all of these crucial zeros, these beats, line up perfectly on a single vertical axis. They call it the critical line.
Which is literally $1 million prize problem, right? Like,
Yeah.
brilliant human minds have agonized over this for 150 years.
Oh, absolutely. And prior to this experiment, humanity had only managed to prove that at least 41.6% of these zeros sit perfectly on that line.
Wow, just 41%. So what did Claude do?
Well, this is the staggering part in the sources. Claude successfully proved that over 2/3 of these zeros lie on the critical line, specifically 67.25%.
That is a massive jump. And what really struck me wasn't just the sheer speed of the AI, but like how it actually got there.
Yeah, the process is the best part.
Because it didn't just instantly crunch the numbers and spit out an answer. It hit a huge wall. It generated hundreds of useless ideas and failed, 650 times?
Yep, 650 failures. It was completely stuck.
So how did it break through?
It only succeeded after a human, a non-mathematician actually, prompted the AI to simply keep going and believe in yourself.
Wait, literally just like my high school calculus teacher.
Literally just like your teacher. It is wild.
That is incredible. So what happened after the pep talk?
Motivated by that prompt, the AI suddenly coordinated 60 different subagents to run thousands of tests. It applied this thing called a Montgomery-Taylor window.
A Montgomery-Taylor window, which, for anyone listening and trying to visualize this, that basically acts like a mathematical magnifying glass, right?
Exactly right. It allowed the AI to isolate and zoom in on these really specific, dense clusters of zeros without getting overwhelmed by all the infinite noise of the rest of the number line.
That makes so much sense.
Yeah, and once it zoomed in, Claude creatively combined prior human techniques. It specifically applied a rank trace inequality.
Okay, and a rank trace inequality is kind of like a complex sorting mechanism.
Basically, yes. It clearly separates the zeros that sit precisely on the critical line from the ones that sort of drift off. And then finally, it produced a formally verified proof in Lean 4.
And Lean 4, that isn't just a regular programming language. It is incredibly rigorous.
Oh, it is notoriously strict.
We're right, because it formally checks every single logical step. So if Lean 4 verifies the proof, there is mathematically no room for error.
None at all. It is flawless.
But looking at all this, an AI coordinating 60 subagents, using magnifying windows, writing flawless Lean 4 proofs in a weekend, it is kind of easy to wonder if human mathematicians are just going to be obsolete cheerleaders from now on.
Oh, I do not see it that way at all. AI is proving to be this incredible collaborative amplifier.
Like a tool rather than a replacement.
Exactly. Claude didn't invent this math from thin air. It synthesized and extended the brilliant foundational groundwork that human mathematicians laid over decades.
Right, so it is really a massive multiplier for human ingenuity. We provide the foundation, the intuition, and I guess the encouragement.
Yes, the pep talks are clearly vital. And then the AI helps us see the patterns we might have missed.
Working together like that, I mean,
Mm-hmm.
humanity is clearly on the verge of solving things we thought were impossible.
The future of collaborative discovery is honestly incredibly bright.
It really is. Which leaves you with a final thought to mull over today. If an AI can push the boundaries of 150-year-old math with just a little human encouragement, what other ancient mysteries could we solve together tomorrow?
That is a great question.
Well, I hope this deep dive helped you wrap your head around these amazing sources. Hey, if you enjoyed this discussion, please subscribe to the show and leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.